Okay, so for this one, hey, this is like a thought problem. It's, hey guys, sit down. So hey, a big point of confusion. I've been doing this problem for many years in class, and kids are like, what is this? A, B, C. Those are just like, just imagine them like, you know, wires hanging from the circuit, and you can hook onto them if you want. So what we're trying to find here is if we put a 5-volt power supply. So for question A, we're sticking the 5-volt battery between points A and B. So it's like this. We're going to stick a battery in like this between points A and B. Now, that means you can forget about C and D. Just take those away. Those will come in later in the problem. Okay, so we have a 5-volt battery in like that. So let's simplify this down. The key to doing circuit problems is to simplify. So what we have, there's the 0.1, like that. Now, the 1, the 10, and the 100, those three are in series because there's no branching through them, so you add those up. So what we have is this. We got 111 ohms, and then this guy down here is 0.1, and then 5-volt battery. So how many currents are in that circuit? Not 2. So there's the current out of the battery. Let's call that I. Now what happens right there? It splits. So we got I1 and I2. So we have 3 different currents in this diagram. Okay, so simplify it again. Circuitry is all about simplifying. Now the interesting thing here is that this resistor here is so small, it's going to dominate in this calculation. Whenever you have resistors in parallel, the equivalent is always smaller than the smallest. So you do the 1 over equation. I'm almost out of time, so I'm not going to show it. This comes out as 0.099 ohms. It's a little bit smaller than the 0.1. And then again, 5 volt. So now what you do is you work your way backwards. So now you can figure out what I is, right? This current here is going like that. So I equals delta V over R. You got 5 volts across 0.099 ohms. So this current here is 50.05 amps. That's the current out of the battery, right? 50.05 amps. Now, guys, shh. What do these two resistors here have in common? The delta V is 5 for both of them, right? The delta V is equal to 5 volts for both of those resistors because they're hooked up to the same points, right? We got 5 volts and 0 volts. So how do we find I1? I1 is going to be 5 volts over 0.1 ohms. So that gives us what? 50 amps. How do we find out what I2 is? I2 is going to be 5 volts over 111 ohms, which comes out as 0.05 amps. Hey man, notice 50 and 0.05 give us what? 50.05, which is the total current out of the battery. Current before splitting must equal current after splitting. And I think we've answered everything here. So look, what's the current in this guy? 0.05. What's the current in this guy? 0.05. What's the current in this guy? 0.05. What's the current in this guy? 50. Ba-bam.